Hi everyone. In this video, I am going to tell you about demultiplexer. Demultiplexer is the opposite action of the multiplexer. It is the reverse operation. We can say reverse operation of a multiplexer. Reverse operation of a multiplexer. Already we have seen what a multiplexer is. Multiplexer has 2 power n number of inputs and one output with n number of selection lines. Opposite is the demultiplexer. That means it has one input with 2 power n number of outputs. Okay, where n indicates the number of selection lines. The number of selection lines is common in both multiplexer and as well as demultiplexer, but the input and outputs are altered. Okay, so a demultiplexer has one input, it has only one input and 2 power n number of outputs. 2 power n number of outputs with n number of selection lines. With n number of selection lines like your multiplexer. Okay, it is also known as data distributor, also known as data distributor, data distributor. Okay, whereas the multiplexer has the other name called data selector, but it is data distributor. The block diagram is here. See, we are having one input, we have only one input, the data line D, with 2 power n number of output lines. 2 power n number of output lines. All these are output lines with a number 2 power n. 2 power n number of output lines, and where n number of selection lines are there. 0, 1, and so on, n minus 1. So totally it is n number of selection lines. So you can write it as S0, S1, and so on, Sn minus 1. Okay, so these are the number of selection lines, and this is the input which will be transferred to the output based upon the number of selection lines. So we can say it is the data distributor. Inside we are having, it is like a switch, and where it is connected with the 2 power n number of outputs. Okay, so based on the selection line, the switch is connected to that particular number line, and automatically the input will be transferred to the output. The size is 1 by 2 power n. Size of the demultiplexer is 1 by 2 power n. So example, if n is equal to 1, 1 by 2. If n is equal to 2, 1 by 4. If n is equal to 3, 1 by 8. Like that, we will be having the size of the demultiplexer. Okay. So the demultiplexer will send the input data D to corresponding output line based on selection lines. Okay, for example, if n is equal to 1, so demultiplexer has a size. Demux has size. What is the size now? 1 by 2 power 1. That is equal to 1 by 2. 1 by 2. So we are having one input D, and with two outputs. So how many number of selection lines? N is equal to 1 means number of selection lines are 1. So if it is yes, so this is output line like O0 and O1. This is 1 by 2 demux. Okay, this is the demultiplexer with 1 by 2 size. We can say like yes, selection lines, yes. Okay, truth table we can take always from the selection lines. So selection lines, yes, and output O0, O1. Okay, if selection line is 0, output will be, the input D will be transferred to O0. So it is D and it is 0. And if selection line is 1, the O0 is 0 and it is 1. It is D. Okay, so depending on the selection line, if selection line is 0, the input will be transferred to the first output line O0. And if selection line is 1, the input will be transferred to the second output line, that is O1. Okay, this is simple 1 by 2 demultiplexer. And if second case, this is the first case, if n is equal to 2, means dmux size is, so dmux has a size 1 by 2 power 2, that is equal to 1 by 4. So how many output lines are there now? 4 output lines with 2 selection lines. So the demultiplexer will be like, so always it is having one input data line. This data line will be sent to 4 output lines. That's why the demultiplexer is known as data distributor. Whatever the data that input contains will be distributed among 2 power n number of outputs. So 1 by 4 demux with the number of selection lines n is equal to 2. So that is like S0, S1 and output O0, O1, O2, O3. How can you write the truth table? So truth table consisting of selection lines S0, S1 and outputs O0, O1, O2, O3. So 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0 means the input will be transferred to O0 and remaining all are zeros. 0, 1 means input will be transferred to the first location and 1, 0 means input will be transferred to the second location. See, the number corresponding to the selection line will give you the result. The number which gives the decimal number which gives the, based upon the selection lines, we are having the output. So all these are zeros and the last one is D. Input data line will be shifted like this depending upon the selection lines inputs. Okay, so in the similar way you can also draw the 8 by 1 by 8 demultiplexer. So third case, if n is equal to 3, if n is equal to 3, so dmux size is 2 power 3, 2 power 3. So 1 by 2 power 3, that is equal to 1 by 8 dmux. 1 by 8 dmux. So the demultiplexer will be, so 1 by 8, n is equal to 3 means we are having one input and 3 selection lines S2, S1, S0, 3 selection lines and total 8 outputs 1, 2, 3, 4, 5, 6, 7, 8. So it is O0, O1, O2, O3, O4, O5, O6 and O7. This is 1 by 8 demux. Okay, 1 by 8 demux. So depending upon the selected lines, the input data will be transferred to the corresponding output line. So how to draw the truth table now? So truth table of 1 by 8 demux is like this. So we are having 3 selection lines S2, S1, S0 and O0, O1, O2, O3, O4, O5, O6 and O7. Total 8 outputs. So 000, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 111. Okay, so when 000 is there, the decimal number corresponding to this one is 0. So D0, O0 will be taking the input data line and remaining all are zeros. Whichever the data is not there, that simply represented by 0 only. And similarly 001 means first location data will be transferred. Okay, clearly see the difference between O and 0 and D. This is D. Okay, don't confuse, this is D. And again, this is 0, this is 0, 1 0 means 2, so data will be transferred to the output line 2, and all these are zeros. And coming to this third one, this is data input D, and all are zeros. And 4, all are zeros. 5, so output D O5 will be taking the output, and here it is D, here all are zeros, the last one is D. Okay, so the output line will be having the input based upon the selection lines. So in this way we can design any type of demultiplexer with different sizes. Okay, one simple method how to okay, suppose consider like 4 by 1 multiplexer, 1 by 4 demultiplexer. Consider this 1 by 4 demultiplexer. How can you write the expression for this output O0? Okay, how can you write the expression for output O0? In the similar way, how to write the expression for this one? Expression for O0 is nothing but here the Boolean expression for outputs like O0 is equal to see, O0 is equal to D when S bar. O0 is equal to D when S bar, and O1 is equal to D when it is S. Okay, this one multiplied with the selection line. Okay, in the similar way, O0 for this 1 by 4 demultiplexer, it is O0 is equal to, see the truth table, output is D only. Okay, output is D, but when it is occurred, S0, S1 both are zeros. So S1 0, S0 also zeros, and similarly it is also 0 when S1 is 0, S0 is 2, and it is D, S1 S0 bar, it is equal to D into S1 S0. Okay, in the similar way you can also draw the you can also write the expression for this 1 by 8 demultiplexer. Okay, see here, this is, you can write it as D S S2 S1 S0 all are bars, all are complemented forms. D into S2 bar S1 bar S0. So like that you can draw the, you can derive these output equations. S2 S1 S0 O7 is equal to D into S2. Every time we will be having the corresponding input line, whichever we are taking, whether it is D or input or whatever it is, the output will be having that particular input value multiplied by the corresponding selection line set. Okay, this is about demultiplexer. Thank you.